This is the first part of a little bit of chemical nomenclature. Now that we've gone through a lot of compounds, a lot of stuff, a lot of introductory material, we're going to go through some stuff that's going to start pertaining to the in society part of the class. We just have a little bit more basic chemistry to get through, and then we'll get into some of that. We have to just do this and a little bit of structure, and then we'll get into some of the more interesting or more applicable stuff. So let's start with this, all right? So nomenclature is naming of compounds. So because there are so many compounds created over the years, it's, you can't just call them whatever you want. And so what we have are both common names and systematic names. So some common names, the names of the elements are common names. So why is it called iron? Someone said, let's call it iron. But you can imagine if you had to memorize the periodic table, how much work that would be. There are two common names, though, that you are responsible for. So one of them is H2O, which is water. So it's not called dihydrogen monoxide, it's called water. And the other one is NH3, which is ammonia. And don't confuse this with the disease pneumonia. Okay, the rest of the names are what are called systematic names. So there are a couple of systems for naming. We're going to just do covalent compounds in this set of slides. Later on, we'll do ionic compounds. You did learn about ionic compounds earlier, but we'll deal with the naming more when we start using them. So we use what's called the IUPAC system, which stands for the International Union for Pure and Applied Chemistry. So there's a meeting every year where they talk about this stuff. And for covalent, the first thing we have to do is some compounds exist in nature as diatomic. So this is, again, a good example. Prefix is di, means two. Okay, and so in this case, the name of the element is the name of the compound. By the way, the smallest piece of a compound is called a molecule, just like the smallest piece of an element is an atom. So there's a lot of ways to memorize these. The way I do it, it's all of the gens. And that's hydrogen, oxygen, nitrogen. And then the group 17 on the periodic table is called the halogens. You don't have to remember that it's called the halogens, but they're fluorine, chlorine, bromine, iodine, astatine, right? So what that means is if we say it reacts with hydrogen, it reacts with H2. If it forms chlorine, it's Cl2. They can have different subscripts when they're combined with other elements, but when they're by themselves, they're diatomic. So you just need to memorize those, that small number. It's 1, 2, 3, 4, 5, 6, 7 of them. But if you remember it's the gens, that'll help you. For the rest of the covalent compounds, we use prefixes, and we use prefix first element name, prefix second, and the second one we make an "-ide" suffix. The prefixes are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And for the first element, if it's just one, we don't say mono. So here we say carbon dioxide, not monocarbon dioxide. And the name is literally, it's carbon and 2 oxygens. All right, so this is where you can use the pause button. Try these on your own, see if you can come up with them. And then, then hit the pause again and go back to it. The next slide has the actual names. So I'll give you a few seconds. All right, so how'd you do? Very good. So this is carbon and 1 oxygen, carbon monoxide. So we do use mono for the first, okay, for the second, excuse me, not for the first. So this is phosphorus and 3 chlorines, phosphorus trichloride. See that? Nitrogen and 2 oxygens, nitrogen dioxide. Right, now let's try going the other way. So you're going to write the formulas. So this is really easy. It's sulfur, 2 oxygens, 2 nitrogens, 1 oxygen. But try it on your own. Hit pause. All right, let's see how you did. All right, very good. Sulfur dioxide, sulfur and 2 oxygens. 2 nitrogens, 1 oxygen, and 2 O. This has a common name. It's called nitrous oxide, but you're not responsible for that. Carbon tetrafluoride, so CF4. Right? So these are actually the easiest to name, and then we're doing those first. But these compounds you're going to see are going to be applicable when we do some air chemistry. All right, now, Elements form compounds through chemical changes. So a chemical change, remember we talked about it before, is when we make new substances. And signs of chemical changes, heat, light, new color, some evidence. This is kind of a cool video. I'll click on it. Theoretically, give it a second to come up. Just watching magnesium burn. Burns very brightly. Look at it go, and woo. There you go. All right, we don't really need to go into that too much. So let's get back to this. Excuse me, let's minimize that. All right, so how do we know that there was a chemical change in that case? Saw a lot of light, also gives off heat. Also, you can tell when you looked at the end, the new substance didn't look like the old substance. Right, so that's pretty much evidence. It's not, heat's not always an indicator, but usually. All right, now to go to the next slide. All right, so reaction with oxygen is called a combustion. It's a specific type of chemical change. So combustion is also called burning. It's also called oxidation. And some other terms, exo, so prefixes. Exo means out. Therm, light temperature. So if something gives off heat, it's an exothermic reaction. If something requires heat, so the environment would get cold, heat goes in, it's an endothermic. But all chemical changes, chemical reactions, are represented by chemical equations. And so we're going to go through that next. And again, this is just a summary. So these are just some pretty pictures that'll show you evidence of a chemical reaction. So we have, why isn't my mouse working? Whoops. There we go. Evidence of a chemical change. All right. Color change. I'll use this. Maybe this will work better. Oops. Guess not. All right. All right. So we represent chemical reactions with chemical equations. There's both qualitative and quantitative. The qualitative is the what. The quantitative is the how much. We're not really going to focus on the quantitative in this class. And we sometimes put the state of a reactant in a parentheses next to the formula, and I'll show you that, but that's not required for this class either, but it's kind of fun to try. On the left side of the equation, we have what are called reactants. On the right side, we have products. So in equation form, we have an arrow. Reactants become products. So just so you can see it, so this is burning methane. So methane is CH4. Burns is combining with oxygen. CO2 and H2O. And if you look at the picture here, all right, you see that there's 2 oxygens on the left, but there's 3 on the right. So, you know, the law of conservation of matter says that that can't happen. So what do we have to do? We have to figure out a way to make it work. But also you'll notice that what happens in a chemical reaction is that the atoms are rearranged. So if you look back, or even if you look here, see how the oxygens are connected to each other, but then over here, they're not connected to each other. So we have to do what's called balancing an equation. And that just means the law of conservation of matter is obeyed, and it's the same number of each atom on both sides of the equation. So we'll go through this example. And the way to do it is just make a list. So this is not balanced. How do we know? Well, if you count, you'll see that there's 2 nitrogens on the left and 2 hydrogens on the left. But on the right, there's only 1 nitrogen and there's 3 hydrogens. So the way we fix this is we have to, well, let's see what it says. Okay, so if we look back at the methane, right, we use coefficients to fix it. So we can't change the subscripts, because if you change the subscripts, you change the substances. So here you can see that now there's the same amount. All right, so these are Rob's rules for balancing. Rule 0, and I have a rule 0 because it is so important, and you might be wondering, well, how important is it? It's so important that you have to do it before you start. So you have to have the correct formula. So that's the nomenclature piece. Once you do that, you never, ever change a subscript. If you change a subscript, the gods of chemistry will become angry, the skies will darken, and a bolt of lightning will hit you. I've seen it happen. It's not pretty. So you don't change a subscript really because it'll change the substance. So if it was CO2, you can't make it CO3 because CO2 and CO3 are not the same thing. So we use coefficients to balance. And then just the other 3 are just guidelines. If an element's by itself, save it for last. Balance of oxygen last, hydrogen next to last. It's just good advice. but you just do it by keeping track. So let's do this. We look at this reaction. So first thing we do is we count. And we've already done that. So now what we need to do, we need to fix the nitrogen. We'll do the nitrogen first. So we'll put a coefficient in front of there. And what we'll do is we'll put a 2 in front of the nitrogen. Now, once you change a coefficient, you have to recount everything. So you can see on the left-hand side, there's still 2 nitrogens and 2 hydrogens. On the right-hand side, though, there are now 2 nitrogens, and there's now 6 hydrogens. So that coefficient distributes through completely. So we'll go to the next slide. Right? So now, how are we going to fix the hydrogen? We can't change it to an H6. What we're going to do is we're going to put a coefficient in front of the hydrogen. That will make it a 6. So what number times 2 is 6? And the answer is, of course, 3. And so we put a 3 there, and now we recount, and you can see that it's balanced. And I will tell you that if you keep going, right, if you go around in a circle, you probably have a formula wrong. So this is how you balance. So now we're just going to do a couple more. All right, so you can click as you go. You can try this on your own, but let's just do this. All right, so we'll count. Right now the carbons, there's 4 and 1. The hydrogens, there's 10 on the left and 2 on the right. The oxygens, there's 2 on the left and 3 on the right. So it's obviously not balanced. So and it doesn't matter what order you go in, but I gave you some suggestions, but be organized. So to fix the carbon, what are we going to do? Okay, you try it first. Right, so we're going to put a 4 in front of the carbon dioxide. So now we're going to recount. So the carbon is now 4 on both sides. The hydrogen's 10 on the left and 2 on the right. That didn't change. The oxygen, though, is 2 on the left, and now it's 9 on the right. How is it 9? Well, you see there's 4 times 2 for the carbon dioxide. That's 8, and then there's 1 for the water. Now, we're not going to balance it yet, but we just want to keep track. So now we're going to balance the hydrogen. Okay, so you tell me what we should do. Try it yourself. That's right. Okay, so now we're going to put we put a 5 in front of the water to fix the hydrogen. And so now we check the math, and you can see that the carbon and the hydrogen are balanced. But now there's 13 oxygens on the right and 2 on the left. How are we going to fix that? Well, here's the thing. We can use fractions. You guys took a little bit of math. It's not a prerequisite, but you've taken some math. So what number times 2 is 13? You can use improper fractions, 13 halves. So let's put that in there. All right. And now you can see it's balanced because 13 halves times 2 is 13. Now, we don't like to leave fractions in balanced equations for various reasons. So what we're going to do is we're going to multiply the whole equation by that denominator, which is a 2. So you see I put 2 in front of the whole thing in parentheses, and now I'm going to distribute it through. So there's 2 C4H10s, 13 oxygens, so 2 times 13 halves. 2 times 4 is 8, and 2 times 5 is 10. Okay, you can verify for yourself that it's balanced. All right, one more. Okay, so let's fix the iron. Put a 2 there. Okay, try this on your own and then just hit pause in between. And you see I'm recounting everything. The iron looks balanced. Now we'll go to the oxygen. So let's use that same trick. Put a 3 halves in front of there. Now it's balanced. So we'll multiply the whole thing by what? By 2. And then we just do the math, and we get that. All right, so you can verify for yourself that it's balanced. So this should get you all the way through homework 3. Okay, try these on your own. Give you a few minutes. Hit pause. And the next slide will have the answers. Are you ready? And those are the answers you can see, and you can verify for yourself that it's balanced. So like I said, this should get you, oh, actually, I'm sorry, I thought we were done. I don't even know my own slides. Welcome to my world. Hydrocarbons are a little tricky, but this is going to come into play when we do some stuff about air. This is a little bit of a long video, I apologize. So you don't need to memorize these, but these are very common. So methane, ethane, propane, you've heard of butane, octane. We're not doing the nomenclature. I'll give you the names. Burning means plus oxygen. So combustion means combines with oxygen. And why do we burn them? Well, why do you burn methane gas? That's how you heat your home, or if you have a gas stove or a propane stove, right? So anytime you burn a hydrocarbon, you are combining with oxygen and you get carbon dioxide and water, right? So try balancing these, and this is how I'm going to present them to you. So burning means plus oxygen at any time. Let's see if I put it here. I didn't. But anytime you burn a hydrocarbon, you're going to get carbon dioxide and water vapor. You do need to memorize that. So that's going to be C5H12 plus O2 makes CO2 and H2O, right? So give yourself a couple minutes to try to balance these. Octane was on the previous slide, so you can look it up. Okay, hit pause. Let's see how you did. So you should have come up with that, all right? All right, now I'm done. So at this point, you should be able to go all the way through homework 3, and that takes care of this material. This is the last of the material that's also on